Hi, the topic that we are going to discuss today is Y parameters. We have already studied what is a two-port network. Two-port network consists of two ports. The first one here that is shown as input port, that is between these two terminals, 1 dash, and another port is also here. It is denoted as 2 dash. There are different parameters that we can obtain from a two-port network. We have already discussed the first category, impedance parameter or set parameters. We are now going to discuss the second category, that is admittance parameter or Y parameter. The other two parameters will be discussed later. Short circuit admittance parameters, or it can also be termed as Y parameters. What do you mean by Y? You might be familiar. Y indicates admittance value. Admittance is simply the reciprocal of impedance. We'll try to explain its presence in the two-port network. We'll start with Ohm's law. Ohm's law explains V is equal to IR or IZ. From this equation, we are trying to explain a relation for I. So we can write it as I is equal to V divided by Z, or 1 by Z into V. We have already mentioned that 1 by Z can be replaced as Y. I is equal to Y into V. Let's have a look how it will appear in the two-port network. Instead of I, we can term it as I1 and I2, as it is a two-port network. And instead of V, we are terming V1 and V2. And for the position of Y, we are expanding the Y terms as Y11, Y12, Y21 and Y22. This matrix format can also be represented as equations. The equation will be like I1 is equal to Y11 into V1 plus Y12 into V2. And the second equation, I2 is equal to Y21 into V1 plus Y22 into V2. Now we are going to evaluate the Y parameter values. The step for obtaining the Y parameter value is to short circuit our network. From the name itself, it is clear that admittance parameter can be obtained by short circuiting the circuit. The short circuiting can be done as a two-step procedure. First one, by short circuiting the input port, and the second case, short circuiting the output port. As the first case, we have picked the second relation, that is short circuiting the output port. We are short circuiting the output port. We know when two terminals are shorted, there won't be any potential difference. So the potential difference will become 0. Here a voltage is mentioned as V2, but as we are going to short circuit this port, the V2 voltage is going to be 0. That means to short circuit an output port means the voltage V2 will become 0. Let's apply this condition in these two equations. In first equation, when we apply V2 is equal to 0, this term gets cancelled and the remaining terms will be I1 is equal to Y11 into V1. We can explain the Y parameter as Y11 is equal to I1 by V1. The same condition can be applied to the second equation. Here, this term will get cancelled and the remaining will be I2 is equal to Y21 into V1. This means Y21 will become I2 divided by V1. These are the two relations that we obtain by applying the condition V2 is equal to 0. Y11 is equal to I1 by V1 when V2 is equal to 0 and Y21 is equal to I2 by V1 when V2 is equal to 0. Let's consider the second case, that is the input port is short circuited. That means the input voltage V1 will become 0. Let's apply this condition in these two equations. In the first equation, these terms will be inactive and the remaining will be I1 is equal to Y12 into V2. That means Y12 is equal to I1 divided by V2. Similarly, the second equation will become I2 is equal to Y22 into V2. That means Y22 is equal to I2 divided by V2. So the parameters that we obtain from this condition are Y12 is equal to I1 by V2 when V1 is equal to 0 and Y22 is equal to I2 by V2 when V1 is equal to 0. Each parameter has got its own name. Y11 indicates it will be seen in the first port, that is our input port. So this parameter can be termed as input admittance, and that too it is obtained from short circuiting the circuit, so it can be termed short circuit input admittance. The next one, Y22. 2 represents the output port, so it can be termed as short circuit output admittance. Y12, 1 and 2. 1 and 2 are involved. That means input and output ports are involved. When both the ports are involved, we will be terming it as transfer. And the direction should also be mentioned as it is from input to output. The direction can be indicated as reverse transfer. And we can term the admittance parameter as short circuit reverse transfer admittance. And the last one, Y21. Here also 2 and 1 are involved. So it will be a transfer condition and the direction can be mentioned as forward because it is from output port to input port. So we are terming it as short circuit forward transfer admittance. We can even directly represent these relations. We know admittance has got the value I by V. And as it is represented as 1, 1, we should represent the numerator and denominator as I1 and V1. Similarly, for writing Y12, we'll write the relation I by V and 1, 2 can be denoted as I1 by V2. Y21, I2 by V1. and y22 I2 by V2. Let's have a detailed picture of this admittance parameter by solving a question. The question is, determine the Y parameters for the circuit shown. We know what are the steps for obtaining the Y parameters. We need to do it in a step-by-step format. We are going to short circuit the output port, and as the next step, we'll short circuit the input port. The first case we have chosen is short circuiting the output port. This terminal should be shorted. The circuit will be like this. By closely examining, we can see a short circuit across a resistor. When there is a short circuited path across a resistor, we know the current will flow only through the easiest path or the resistance free path. So there won't be any current flow through this 8 ohm resistor. We need not have to consider this 8 ohm resistor. Let's draw the circuit once again. The circuit has reduced to this level. Now we will evaluate the parameter values. Here the V2 voltage is 0. With such a condition, we are going to get two relations, Y11 and Y21. First, we will pick the relation Y11. Here, Y11 has got the relation I1 by V1. We are adopting the same steps that we have done already with the set parameter values. Here, the numerator and the denominator are unknown values. We have to find the value of Y parameter from these unknown terms. So what we are going to do is, we are going to make numerator or the denominator of similar terms. For example, if I am able to represent this V1 value in terms of I1, then the equation will have similar terms both in the numerator and in the denominator. Then it will be easy for us to simplify the relation. Let's try to obtain a relation for V1. V1 is seen here in this position, and we can say that V1 is a voltage that is experienced across this 4 ohm resistor. The potential drop can be expressed as I into R. That means V1 is equal to the current through 4 ohm into 4 ohm. How can we get the value of current flowing through this 4 ohm resistor? Let's examine this circuit. A current is entering into the circuit, and after reaching this point, current flows into two different paths. We have to find the amount of current that is flowing through this branch. To easily analyze this, we are taking the help of current division rule. You might be familiar with the current division law. Current division law states that current through any branch will be equal to total current into resistance at other branch divided by total resistance. So we will complete the equation as current through 4 ohm will be total current I1 into resistance in other branch 6 divided by total resistance. We can write it as I1 into 3 by 5. After obtaining this relation, we can substitute this value in our first equation. Then it will be like V1 is equal to current through 4 ohm into 4. That is, V1 is equal to I1 into 3 by 5 into 4. Just have a close look on this expression. V1 is now expressed in terms of I1. The expression for Y11 is I1 by V1. The numerator is I1 and now our denominator has also become in terms of I1. When substituting, we can write it as I1 divided by I1 into 3 by 5 into 4. That means we'll obtain the first Y11 value as 5 by 12 more. Admittance parameter is a reciprocal of impedance. So we can write the unit as ohm inverse or mho. The other parameter that we obtain after setting V2 is equal to 0 is Y21. Y21 is equal to I2 by V1. Here also, the numerator and denominator are entirely different terms. We'll try to make the numerator and denominator of similar terms. We have already obtained the relation for V1. V1 is expressed in terms of I1. Now we'll try whether we will be able to change this numerator and make it in terms of I1. I2 is seen here. The total current flowed till this point. After this point, it got split into these two branches. The first branch, we have calculated it as the current flowing through 4 ohm resistor. And the current through this branch will be termed as I2. So, to obtain the I2 value, we are again applying current division law. Current through 6 ohm is equal to total current I1 into resistance at other branch 4 ohm divided by total resistance 6 plus 4. That means I2 is equal to I1 into 4 by 10. You have noticed a negative sign over here. It's just because the current direction has been reversed here. We can even write it as minus I1 into 2 by 5. Now, the numerator has also become in terms of I1. So, we'll try to get a relation for Y21. Y21 is equal to I2 divided by V1. The similar terms cancel each other and we can simplify it as minus 1 by 6 more. The other step that we have left with is short circuiting the input port. We need to short circuit these two terminals. By short circuiting, the V1 value will become 0. Let's redraw the circuit. Here also, we can find a shorted path across a resistor. So, the 4 ohm resistor will become inactive here. We can now draw a simplified circuit. The two parameters that we obtain from this condition is Y12 and Y22. We'll consider the first case Y12. The numerator is I1 and the denominator is V2. We'll try to change this V2 value. V2 is seen here. V2 is seen in the same terminal position as that of 8 ohm. So, we can term V2 as the potential difference across the resistor 8 ohm. The potential across 8 ohm resistor can be found as I into R. That means the current through 8 ohm into 8 ohm resistance. We can find the current through 8 ohm using current division rule. That means current through 8 ohm is equal to total current I2 into resistance in other branch 6 divided by total resistance 6 plus 8. It gets simplified as I2 into 3 by 7. That means we can obtain V2 value as V2 is equal to current through 8 ohm into 8. So we'll get it as I2 into 24 by 7. The expression for Y12 had V2 in the denominator position. The denominator now has changed in terms of I2. But here the numerator is I1. We have only obtained denominator in terms of I2. So we'll try to change this numerator also. Our requirement is to get I1 value in terms of I2. Here, I2 will act as a current source. This current will split into these two branches, that is the current through 8 ohm and the current through 6 ohm, that is mentioned as I1. So we can get the I1 current using current division rule. I1 is equal to total current I2 into resistance in other branch 8 divided by total resistance 14. Here also we have put a negative sign just to indicate the reverse current direction. Here the numerator and denominator of Y12 expression has now become in terms of I2. We'll now complete the relation. Y12 is equal to I1 divided by V2. After cancelling these similar terms, we'll get a simplified answer as minus 1 by 6 mho. We are left with one more term, Y22. Y22 is equal to I2 by V2. We already have a relation for V2 as V2 is equal to I2 into 24 by 7. Now our denominator is in terms of I2. Numerator and denominator are of similar terms. So we can simplify this easily. Y22 is equal to I2 divided by V2 term, that is I2 into 24 by 7. So we'll get the final answer 7 by 24 mho. We have now obtained our final answer. Y11 is equal to 5 by 12 mho, Y12 is equal to minus 1 by 6 mho, Y21 is equal to minus 1 by 6 mho, and Y22 is equal to 7 by 24 mho. We can solve the same question using a simple method. This circuit is having a pie shape. The components are arranged in a pie format. If our network is a simple pie-shaped network, then we can go for the simple method. Here, we can find a node over here. Node means just a simple junction. 3 branches meet over here and it can be termed as a node. We have marked the first node as A and the second node as B. We'll first apply KCL at node A. KCL means Kirchhoff's current law. Kirchhoff's current law mentions the algebraic sum of currents in a point will be equal to 0. That means the sum of currents entering a point will be equal to the sum of currents leaving that point. Here, I1 is the current that enter into the point and I3 and I4 leaves that point. So it can be written as I1 is equal to I3 plus I4. We'll try to solve this equation. I3 is the current that is flowing through this branch. The resistor value is 4 ohm and the voltage across this resistor value is V1. So we can express I3 as V1 divided by 4 using Ohm's law. I have termed I4 over here. We can even express I4 according to the Ohm's law. The potential across node A is denoted as V1 and the potential across node B is denoted as V2. So, the potential across 6 ohm will be the potential difference between these 2 points. So, we can write it as V1 minus V2. So, the current can be written as I4 is equal to V1 minus V2 divided by 6. We'll complete the relation. I1 is equal to V1 by 4 plus V1 minus V2 by 6. We'll complete the relation as V1 by 4 plus V1 minus V2 by 6. It can be simplified. V1 by 4 plus V1 by 6 minus V2 by 6. When simplifying the V1 terms, we get it as 10 V1 by 24 minus V2 by 6. And we can get a simplified equation as I1 is equal to 5V1 divided by 12 minus V2 by 6. Note down this as our first equation. In a similar manner, we are going to solve this node B. Applying KCL at node B, the sum of currents entering I4 and I2 are entering. So it can be written as I2 plus I4 is equal to the sum of currents leaving. Only I5 current is leaving that point. So I2 plus I4 is equal to I5. We'll get an expression for I2. I2 is equal to I5 minus I4. We have got the expression for I4. The remaining is I5. I5 is the current that flows through 8 ohm. 8 ohm experiences a voltage V2. So, to find the value of current, we will apply Ohm's law. I5 is equal to V2 divided by 8. By substituting, we will get it as I2 is equal to V2 by 8 minus the relation for I4, V1 minus V2 by 6. We can simplify it as 14V2 by 48 minus V1 by 6. And our relation will be I2 is equal to 7V2 by 24 minus V1 by 6. And this will be our second relation. We'll compare these two equations with the standard Y parameter equations. When compared, we can see that these two relations keep a similar format. That means I1 is equal to Y11 into V1 plus Y12 into V2. In the position of Y11, we can find 5 by 12. And for the position of Y12, we can find minus 1 by 6. So we can write it as Y11 is equal to 5 by 12 more and Y12 is equal to minus 1 by 6 more. Similarly, we can examine the second equation as minus 1 by 6 is seen in the position of Y21 and 7 by 24 in the position of Y22. Thus, we will get the values Y21 is equal to minus 1 by 6 more and Y22 is equal to 7 by 24 more. And we have obtained the same final answer as before. This seems to be very simple, but it can only be applied when our network is having a pie-shaped arrangement. Thank you for watching.